Hi, greetings from Scotland. I've been watching your YouTube videos, trying to keep up with the tutorials the best I can. I'm just really getting into CAD. My first program was SketchUp, but it had a few limitations for me. Or maybe I was just bad. I've been trying to design various ant formicariums, outworlds, perplex housing, etc. I bought a 3D printer from Bamboo Lab and have a Fox Alien CNC en route to me. I thought about selling the items I print out or CNC, but I need a really good design and I'm limited in my abilities. I could use Fiverr, but I really like your way of training. My question is, would you be interested in putting my ideas into Fusion and also doing a design along with me style video so I can learn as well? Always learning, Darran. So when I received that email, my first question was, what is an ant formicarium? So I looked it up and I found that a formicarium is an ant farm which is designed primarily for the study of ant colonies and how ants behave and for the enjoyment of ants as pets. So this was a personal request of somebody that I don't know. He contacted me, contacted us with our contact email on our About page, and he asked if I could do this for him. Well, I thought about it and I thought, what a great tutorial this would be. And although I didn't know what this was, and I'm sure that most of the viewers out there have no idea what this is as well, there are a bunch of different things that we're going to learn with this tutorial that I think you would thoroughly enjoy. And so if we look at our parameters here, we have made this fully parametric. So if I change the width, there it changes. I can change the height. I can change the depth. I can change all of these different items so that we can make this ant formicarium. And I think you would have a wonderful time learning along with us. Oh, and if you had a suggestion for a tutorial in the future on our channel, if you like the way that we instruct, feel free to send us an email and we'll definitely consider it. So let's get into it. So the first thing that we're going to do with this ant formicarium is break it down into individual components and then the display box. So this is acrylic. And then we have the box and holding tank, which is everything. So we're going to start off with this. And again, sometimes we have to use our imagination. We have to picture, deconstruct the project in our minds and then start with that individual component. So that's what we're going to do right off the bat. We're going to call it our box and holding tank. So let's create a new file. I'm going to save this right away. And we're going to call this Formicarium tutorial. So again, the very first thing that we do is create a new component. So we're going to create it right here, new component. And I'm going to name this box and holding tank. Now at this point, we can start thinking of all of our parameters if we're able to. So for me, I know that the width, the depth, and the height are going to change. And then also this holding tank over here, the width, the depth, and the height are also going to change. So let's put all of those parameters in. So just as a quick review, we can see here that we've got the main box width, height, and depth, and then the holding tank width, height, and depth. So that's looking great to me. These are just generic numbers. Of course, I've based it slightly on the original design of the user request, but this is the point of parameters, as we can change it depending on what we want in the future. So once we've created our component, you can see that our component down here, box and holding tank, is active. This means that our timeline will be created all underneath this individual component. So let's start off with a sketch, and you can see once we create it, you'll see that we have a sketch in the bottom there, which is the first tool or first item in our timeline. So let's create a center rectangle. And here, because we've already created the parameters, we can just type them in. So this is going to be our height. And again, you can just type in one individual letter and then find that parameter. So I'm going to go to main box height, press enter. That locks it in. Then press tab to go to the next one. So we can zoom out and you can see that right now I'm on the next dimension there. So again, tab goes back and forth. Pay attention to how many times you press enter. Enter just locks it in, the original parameter. And then if you press enter again, it would completely finish the sketch. So pay attention to how many times you press enter. try and get used to using tab more and more. So again, I'm going to go WI for width, main box. I'm just going to hit enter. Now you can see I can still go back and forth between those two dimensions, but I want to lock it in now. That's exactly what I want. So let's go enter. And there we have it. Let's finish our sketch. And now we can add, and actually I'm looking at this now, we should have created it on the other plane. So let's just delete this here. I'm going to create another sketch and we should create it on the XZ plane. Again, I'm going to try and make it so that it actually looks like the finished product. It's not the biggest deal in the world, but I like doing it just to hold to a little bit better standards. So let's just do that. And this is the main box width. There we go. Finish sketch. And now we can extrude it. I'm going to try and keep everything based off of the origin being on the inside. So let's just type in depth here, main box depth. And for this, I'm going to go to symmetric. You can see it adds 20 mils to the back, 20 mils to the front, but I want 20 mils total. So this is where I pick whole length right there. Perfect. Let's go OK. Now here is the main box of our ant Formicarium. Now we need to answer the question, should we create the holding box first, or should we shell out this box? Well, if we shell it out, it's going to just create a few more problems for the holding box. So at this point, I'd probably want to create the holding box. Let's go to create sketch. I'm going to create it on this face. Again, it matters what you select. So I can, select this front face here. It turns slightly different shade of gray and does that for each face. Let's just pick this face. And when I create a sketch on a face, it inherits all that geometry. So all this geometry on that face, if I hide the body right now, you can see all the geometry is still there, which is great. But what I want to do is create a 2-point rectangle. And here I'm going to create the height, our holding tank height. And again, tab to go to the next one. We're going to go width, holding tank width. And there we have it. Now that we have both of those, we can just go extrude. And this is going to be our holding tank depth, just like so. Now, here we run into a little issue. I'm going to bring up the parameter box over there. And again, I can't stress this enough. Bring your part down to the bottom left. Bring your window up to the top right so that you can see the parameters change in real time. So many people, they hide their part behind their parameter box. They change all of it and they can't see what's happening. Well, this is designed to update automatically. And you can see here automatic compute is selected. So this will adjust in real time. Now it's good to note that we should check our parameters often. We design, we check. We design more, we check. We all do it in steps. It's very rare that you can create a part with numerous parameters and then at the very end make sure that everything is working perfectly. Usually there's a lot of errors that you have to fix. Well, it's better to fix those in progression. So let's just check. Here we go. Main box width. I'm going to go 400 mils. And there we go. That's looking great. 300. That's looking great. Our depth, we can make it deeper. Excellent. Now, what about our holding tank? Well, let's try it. And everything is looking amazing. Very, very good. Now, here's something we're going to change right now. I don't want to make it so that if I accidentally type in the holding tank width, let's go bigger or wider than my main box. Well, obviously, this is not what we want. So I'm going to type in a formula here. I'm going to say that I always wanted half the width of our main box width. So let's just type that in, main box width. And then we're going to go divided by 2. So no matter what our main box width is, the holding tank width is going to be this value divided by 2. And you can see the calculated value over here is at 200 mils right now. I'm going to do the same thing with the height. There we go. So we have a calculated value right now. It's always going to be half that. And then the holding tank depth, well, this I want to be able to adjust. But let's just see what happens here. If I go 300 mil, well, then the width of the holding tank also goes down in half. So now it's at 150. And let's do the same thing for 200. So this is looking great. That's looking really, really good. So let's just bring this back up to 350 and 200 mils and this down to 40. So there we go. So now let's create a new parameter, and we're going to call this our wall thickness. So again, I've mentioned this in past tutorials or in other tutorials. If you haven't seen them, please check them out. We can't put a space in there. As soon as we do, these become red. So we can either put an underscore or we can just separate them by capitals. So you can see there, wall, W is capitalized, and then thickness, the T is capitalized. So we're just going to call this a simple 5 mil wall thickness. Now this is great. We're going to go right into shell, and shell is really underrated or not used as much as it should. What we can do is pick an individual face, and we can just type in wall thickness there, and it will create this shell all the way around. Now the problem with this is you can see it's creating a shell all throughout through the whole box. This is not what we want, so we can't use shelling right now. What we're going to have to do is create another sketch on this face. Remember, when we create sketches on faces, it inherits all that geometry. Again, I can prove it to you by hiding the body, and there's all of the geometry that we can select that's on that face. So now what we can do is let's create, well, an offset. Let's do that, and we can pick this chain. Chain selection is on, so it picks all of the lines or the edges that are connected together. So we're just going to bring this down, minus wall thickness. And there's that. We want to create another one because this is going to have a little lip on the inside for the acrylic to lay on. So we're going to go there. We cannot pick this line actually. As soon as we try and pick the offsetted line, it brings up an error in the bottom. So we have to pick the original line or the original chain, and then we're going to go minus wall thickness times 2. There we go. So we've got these two profiles now that we can pick. Let's go finish sketch. And it really doesn't matter what we pick at this point, but what I'm going to do is I'm going to extrude the first or the inner profile right now. Let's pick that. And I want to make this so that it will always be 5 mils from this bottom face. So let's pick this here. We're going to go to extent type to object. Let's pick that bottom face. We don't want it to go all the way through. So now this is where we use this offset, and I'm going to go to wall thickness. This is going the wrong way. This is going even further. You can see that down here. The extrude is going even further. So I just have to call this a negative wall offset. And there we have it. So this is going to cut. Now you can see that our sketch is hidden. Once we create an extrude or we use any of these tools with a sketch, it hides the sketch automatically. Fusion is smart, and it thinks that once we have done some sort of operation with a sketch, that we don't want to see that sketch anymore, and it hides it. But it's not gone permanently. We just have to open up our browser and activate that sketch or make it visible, and it will bring back that previous sketch that was just hidden. So let's extrude this now. We're going to pick that profile. We're going to go down, and this is going to be our wall thickness as well. Very good. Now we can hide that sketch. That sketch is now brought back permanently until we hide it. So we can hide that eyeball right there. So what's the difference between hiding the folder itself or the individual sketches under its main folder? Well, these will bring up the individual sketches where this will hide all of them. And if we hide all of them, as soon as we go to create another sketch, it's probably going to bring up an alarm. No, it's not. So what's better is to leave this on, leave this visible as the master folder, and then all of the individual sketches underneath that folder, those are the ones that you can hide. It keeps your project a lot more tidy and a lot more understood. Anyways, now that we've got this, we can now do the same thing to our holding box. So we're going to create another sketch there. Let's just create it on that face. And here we can't do an offset because that's going to offset all of those different edges. So let's turn off our chain selection in order to use this. And we're going to pick 1, 2, 3. Let's bring this over, minus wall thickness. And we're going to do the same thing to create another one. 1, 2, and 3. And this is going to be minus wall thickness divided, or times 2, I should say. There we go. And actually what we can do is go back to that sketch, and this second offset, this is where we can actually put this as a dimensioned value for our wall thickness right there. So you'll see it in a moment why we can select it like that. But this is looking great. A lot, they worry about using the trim tool. They want to make their lines and their sketches all pretty and perfect, but it's not needed. We can pick these individual profiles or these individual sections and extrude them. We can pick several of them if we want. So sometimes trimming, it gets rid of constraints. It ends up making your drawing even more complicated. So just use your imagination. Look at the end result that you want and draw them as solid lines. It's fine. So now we're going to go extrude. Let's extrude. And I just realized a problem, but that's okay. Let's fix it in a moment. This is going to be good. So let's go all the way back. And again, here, we're going to go to an object. We're going to pick that. And our offset here is going to be minus wall thickness. Beautiful. Make our sketch visible again. And we can extrude. And here you can see the issue. We should have actually created a line all the way through over there. So this is going to be really easy. Let's just go back to our sketch. We're going to edit it. And we can extend. Let's go to modify, extend. And we're just going to pick that line and that line. Very good. Now what we can do is, believe it or not, we can, let's pick those three. This is going to be minus wall thickness right there. And then what we can do is pick these two lines. And at this point, we can just go to an object and select that face. There we have it. So that's just one way of doing it. There's a ton of different ways of doing this. Everyone, that might have not been the best way, but it's just showing you different tools to get to the same result. Again, this only took me a couple minutes to do that extrude, so don't worry too much about finding the perfect way of doing it when you're worried about timing. That is a good way of doing it as long as the parameters work, which brings us back to testing our parameters. So we've done a few different operations over here. Let's test our parameters. Go there, 400 mils, that's looking great. So basically we're looking for anything that's breaking right now. And again, wall thickness might be the one that starts breaking. Let's just test. That's not breaking at all. That's looking great. So we're just looking for errors. We're looking for anything that might be messing up on us. Let's go okay. So here's one thing that I forgot earlier. If we look at our original file, you can see that we have big loopy fillets over here on the corner. Now, it's probably a whole lot better if we put that on early. And you can see that if we specify this outer fillet first, this is at 20 mils. Well, if we design it right, we don't have to specify these other interior fillets. Fusion will do that automatically for us. So let's do that. We just have to do it at the right time. So we're going to go back in time with our timeline here. And let's create a fillet. Put it right there. We're just going to call this 20 mils. There we go. So let's just save this. We're getting some errors here about saving. Perfect. Now again, that's going to be okay. Let's check out this sketch. Now this sketch, there is an issue. Again, we've created this sketch earlier. Now we've got a few issues to contend with. And again, this is why we check our parameters often. We make sure our model is looking great before we proceed. Now, we actually have to delete all these in order to utilize that fillet that we've just created. So what's the easiest way? We can pick these all as individual lines or just double click and it will pick that entire profile. So let's delete that, double click, delete that. Again, now let's create our offset. We're going to pick chain selection. And now you can see what I'm saying is as we utilize that fillet, our wall thickness and that fillet, depending on the offset, will adjust correspondingly. So it's better to do it this way. So we're going to go minus wall thickness there, create another one. Minus wall thickness times 2. There we go. Finish sketch. Now we're probably going to get into some alarms here. Yeah, right now it's saying, okay, well, you've created an extrude. It's using some sort of edge or something, a sketch that you've used in the past, but that has changed. So you've got an alarm here. So now it's saying missing profiles. We're just going to pick that same profile that we picked before. this is going to bring up the same issue. So missing profiles, let's pick the correct one. There we go. Everything is looking great. This should all be fine. And there we have it. So I'm happy with the box and the holding tank right now. I can worry about the little passageway for the ants over here and the test tube dimension for the top and the side, but why don't we just leave that till later? So now what we'd like to do is create a new component, and I'm going to create the acrylic that goes here for our main box. So if I were to go up to create and go new component, well, where is it going to create it? It's actually going to create it underneath our box and holding tank as component 2.1. So I don't want to do that. What I like to encourage my students to get into the habit of is right-clicking the actual component that you want to create a new component in. In this case, we're going to create a component in our master assembly here. So right-click, new component, and this we're just going to call it our box display. Now you can see that underneath our master assembly, we have our box and holding tank and our box display. And again, the point of using components is to keep everything tidy, to keep everything organized, and we can use joints and all of that as well to make our 3D file and our assembly functional. So as soon as we create a new component, you can see here this little bullseye. It means that it's activated and there's nothing in our timeline. If we want to adjust something in our box and holding tank, we go there, we select it, it activates it, and there's all of the items under our timeline. If we activate our master assembly, then it's everything that we've ever created within this particular file. So let's go back to our box display. You can now see that our box and holding tank become transparent. And that's saying that we can use this to base our next component or our next design on. So for example, we want to use all this geometry in the, for example, this face, this set of faces right there is going to be the basis for our box display. So let's activate box display. We're going to create a sketch on this face. Now this is a little hard for some. You just have to make sure your mouse cursor is located right above the face that you want to select, and it should select that by default. We can click our mouse and go finish sketch. And now remember what I said before, as soon as we create a sketch on a particular face, it inherits all that geometry. So let's hide our box and holding tank and look at this. There's all of our geometry that we have selected. And so this is the inner profile. And then you can see here, this is that lip right there. And basically, we want to use both of those in order to create our acrylic display. Now, I didn't actually have to create it on that inner lip or that shoulder. I could have created it on the top, but this is just showing you another way of doing it. So I'm going to pick both of those profiles to extrude. We're going to go up, wall thickness, and there we have it. So we've got now our box and holding tank there, and then our box display is going to be right there, which is looking great. Now in real life, if we were to cut this out, the acrylic out with a laser, some sort of laser machine, laser cutter, and then 3D print this box, well, you can see that these two components would not mate up perfectly. So what do we want to do? Well, we would probably want to inset all those faces a certain value. We're going to do that later, but basically we want to create a little relief, a gap in between all those. And for that, I'm going to create a parameter because it's something that we want to probably change in the future. So let's create another one called relief. And I'm going to make this really small. Let's just go, let's go to 0.5 mils right there. So we're going to use that later on. Very good. So next, I want to create the top of our holding tank here. So let's create a new component. Again, right click there, new component. We'll call this holding tank top. Very good. So now let's create a sketch. And here I'm going to do kind of the opposite of what I did with the front display. I'll just select the top face. And remember, it was going to inherit all of this geometry. I want to just create a line from that corner to this corner. And now I can create or select this inner face right there. Let's do that. Let's just talk about this real quick. What I could do, and I didn't do it with this front display, I'm going to create the relief right now. May as well, let's just do it. We're going to go back to that sketch. I'm going to go to the offset command. And here again, we don't want to pick the chain selection because it's going to pick that entire outer chain. So we're going to turn that off. And we're going to pick these 4 lines right there, those 4 edges. And we can just type in our relief value right there. Now the benefit of doing this is once we finish our sketch, we can just grab our extrude and we can extrude this in. But the problem with this is that there's going to be this little front of our top of our box here that's going to be inset, and we don't really like that. But this is very easy. So let's just go minus wall thickness. First of all, we like the relief on this side, the back side there, and the right side. But on the front, we can just go to press pull. I'm going to pick this face and we're going to extend it. Actually, let's not go press pull. Let's go to extrude and pick that. There we go. And we're going to bring this out our relief amount. So now it should be flush. There we go. It's looking great, but everything else has a relief to it, which is looking great. So now we're going to create another component. This is going to be our holding tank display. We're going to do the exact same thing down here. So let's create a sketch. And again, I'd like to orbit so I can easily pick the face. If I were to go like this, sometimes it's hard to see exactly what you're trying to pick. So I like to orbit the part, go to a face that has nothing beside it, and it's a lot easier to see the grid pattern. So there we go. Now it's picking everything there, which is looking really good. And we can do the exact same thing. Why don't we just create a line here from there to there? And here we can just create a dimension. So these are all just different ways. I'm not trying to throw everyone off with always choosing a different method or a different way to do this. I'm just showing different ways to come to the same result. Sometimes you want one over the other. But in this instance, I'm again just showing different ways here. So let's go to offset and we can now pick these lines. 1. Oh, it's not letting us do it. So let's go here. So we can go offset. Yeah, 1, 2, and 3. That's right. And it's going to meet up with that line. Now I do want this line to be offset right there. So why don't we just put that in right now? We can just simply do that with our dimension. So we're going to double click wall thickness plus relief. That's going to make it a little bit further from the edge there. And we're going to go OK. Oh, and I forgot to put in an actual value for this relief. This is only one mil, so we want to make sure to actually put a value there, relief. There we go. Now we can extrude it from there, and we're going to go in our wall thickness. Perfect. So now you can see there's this relief all on all sides of our acrylic front display for that holding box. This is looking great. So again, look at underneath our holding tank display, we've only got 2 items. We've got a sketch and we've got our extrude. If we go to our top, we've got 3. If we go to our box display, again, we've only got a couple there. And then our box and holding tank has a bunch. And if we go to our master assembly, it has every single tool or operation that we've used so far. So let's save. And again, at this point, let's just check our parameters. Make sure that our parameters are not breaking on us. So let's go 500 mils. That's looking great. 200. Very, very good. Let's go to our depth of 50. Awesome. Everything's updating automatically. And our tank depth, let's go 5. And our wall thickness, why not? Let's just go 10 mils. Very good. And our relief as well. Let's say we need more of a relief. Oh, everything is looking great. We're just going to inspect it. That's looking fine. You can see that our front display here has not been updated. So let's just look at one other way to do this relief. So let's go OK. There's a ton of different ways, again, to do this. But let's go to our box display here. I'm going to activate it. Why don't we hide everything else? Here I'm just going to go right click on the box display and go isolate. Now it's going to hide everything else and make sure that our box display is active. So why don't we just do this? I'm going to create a sketch on that face. Remember, it inherits all of our geometry, so I can create an offset now. Let's pick chain selection. This is in the negative direction, so we're going to go minus relief. There we go. Finish the sketch. And now what we can do is extrude it. This should be one profile, one closed profile all the way around. And we can go all the way through. Let's go to an object to the underside there. And now we've got this relief all the way around. So to unisolate, we're just going to right click, unisolate, and now everything is looking great. We can see this relief all the way around. It's looking really, really good. So now what do we want to do? Well, I would probably want to insert all of the hole locations for our fasteners. So let's start with our box and holding tank over here. I'm going to isolate that. And what we're going to do is create a sketch on this face. And we could use an offset. We could go here to minus wall thickness divided by 2, and it's going to create an offset all the way around there. Now, the only problem with this is, because I've experienced this with the original model that I practiced on, is that in the future when we adjust our parameters, this offset breaks for some reason. So I'd like to try a little bit of a different method rather than using this offset here. So I'm going to delete that. And now I'm going to use construction lines and center points to center exactly where I want to put all of my fasteners. Well, basically the holes right now. So we're going to create lines. We're going to go over here to construction. We can also press X on our keyboard. It will do the exact same thing. Just to let you know, I've got a little display here for the keyboard of each command. If you haven't observed that already, it's very handy. And now what I'm going to do is find those midpoints. So you can see as I scroll my mouse over here, it selects the midpoint by default. So I'm going to pick that and that right there. And I'm going to follow the outline or the sample that was sent to me of how many holes and how many fasteners there are. So I'm just going to pick all those different edges right there. Now this one as well, this is going to be the midpoint right there. And again, the reason I'm doing this is because outline, or offset I should say, it broke on me in the past with the parameters. So I don't want to show you that breaking. You can try it on your own. But here I'm just going to show you that I'm going to connect those points with a line that is fully constrained. And we're going to use those for our points for our holes as well. So I'm going to go to point now, create a point, and just pick the midpoint of all those. And there we have it. Let's go finish sketch. So now we've got all of those points. And what I'm observing here is this guy. Oh, and do you know what? We've created a sketch in our master assembly, and it's created a new folder called sketches. We don't want that actually. So I'm going to delete this sketch down there, and I have to remember to go to box and holding tank, make it active, and then create a sketch on that face. So let's do the exact same thing. I'll be quick here. And I just realized that this line, I want to actually connect to the midpoint of this inner wall rather than right here. And let's just do that. I'm just going to create a line going like this. And then I'm going to take this point and I'm going to say I want it connected to the midpoint of that line. And it should place it right where we'd like it. So let's go create our points. Finish our sketch. Now let's just go to our browser, and you can see here that our sketch has a little lock beside it, and this means that it's fully constrained. All of our points are constrained. It will not break on us in the future, or will not mess up in that a point that's unconstrained will just be floating in space somewhere. So there we go. So now that we have that, we're still active on our box and holding tank. Let's create our holes. Actually, before we create our holes, what we'd like to use here are going to be our threaded inserts. So we're going to go to insert a McMaster car component, and let's find a threaded insert. Here under helical inserts, we can go to, actually I think it's under threaded inserts. There we go. If we scroll down, we can try and find press fit. There we go. Heat set inserts for plastic. Now, if you're looking for these heat set inserts, I've included a link down in the description below for one that I'd like to recommend. It's a whole set of different inserts. Check it out. Might be something that you'd be interested in getting. So let's go there and let's just look at the different kinds that we have. So let's go down to metric and we're going to pick, and again, this is not something that we can use with parameters. We have to pick an individual item and then use that particular item in our design. So I'm going to pick a thread size. Let's go to a 2.5. Here we go. Yeah, maybe the 3 mil. And then our installed length is 3.8. And our drill bit size is going to be a number 8 or 0.199. So let's remember these. We've got to pick a length of 3.8 mils. And then the drill is going to be, or the hole size, 0.199. So 3.8199. And we're going to go over here to our part. There we go. And we are going to pick our step file. Now, I'm going to purposefully do this as a mistake. I'm going to download it. And let's just make sure that we grab our part number here. I'm going to save this part number. I'll do that later. Okay, so let's just go download as a step file and download it. You can move this off to the side and go OK. And there's this little threaded insert that we're going to use for our design over here. Now, I purposely made a mistake. I ended up inserting it into the box and holding tank. Well, I don't want to do that. I want to create a whole new folder where it's going to host all of our fasteners together. So one thing I want to do, I don't want to search for that insert once again. So I'm just going to highlight this number. We're going to copy it. And then what I'm going to do is just go back in time. I'm going to go undo, undo. And instead of activating the box and holding tank, let's create a new component. We're going to call this our fasteners. There we go. And now we can go back to McMaster car. And because I saved that number, I'm going to paste it and go enter. And it will bring it up right there by default. I don't have to search for it again because I searched it by its part number. Now we can download the step file. Perfect. We're just going to leave it there floating. It's okay. It's in our background right there. We don't have to worry about it. If we were to move it, oh, and I've done this wrong. So just to show you, yeah, I just moved the box and I don't want it to move. I am going to go to revert. And we're going to right click the box and holding tank and ground it. So now I can not, move it by accident there. And now if I select the threaded insert in our browser, I can just move that off to the side. But as soon as I create a new operation, it's going to bring up an alarm saying, do you want to capture this location or revert? And this is what it means, is I have moved this insert just off to the side. In reality, I want to revert it. I don't want to joint it right now to its proper location. I just need to create the holes first. So remember, based on what we saw in McMaster, I need to create the holes 0.199 inches and 3.8 millimeters deep. So let's go back to our holding tank. Let's go to our hole command. So let's now pick those individual center points. It doesn't really matter the size right now. We're going to adjust that in a moment. Let's go over there. Perfect. And we can go to, I'd like to create a little bit of a countersink. It just makes those threaded inserts go in a little bit better. So this is going to be a flat bottom, and this is going to be our 0.199, and we can type IN for inches. Oh, that's not working. 0.199. Oh, we can't specify this as being inches right there, so that's okay. Oh, now I've lost it all. Let's go back to hole, find those again real quick. So this is good for us to remember the formula for millimeters to inches. So we're going to go 0.199 times 25.4. Great. And this is going to be 3.8 millimeters deep. And there we go. That's the size of our threaded inserts for the locating those threaded inserts or installing them. So again, we want to do a little countersink there. And that reminded me, if we put in our dimensions first, our bore diameter and our depth, and then click countersink, it will automatically calculate a small countersink that will fit that particular hole size. So let's go OK. And again here, the formula for inches to metric is 25.4. So let's go OK. So you can see now it's at the center point of all of those of the profile. And here, this is where parameters really work for us. So our wall thickness is at 10 millimeters right now. Let's go to our 5 mil and let's see, does it actually work for us? And you can see that it is, I think it is spot on. Yeah, I think it's just going to work just fine. Oh, this one is not. This one is being all crazy on us over there. Let's check the others. Those are all at the center point. Those are looking good. This one is not really looking so good either. So this thread insert is probably a little bit big for what we would like. Why don't we just go and use a smaller one? So I'm going to do that. Let's do that real quick. We can keep that whole command. And what I can do is let's go into that sketch right here. And you can see that our hole was, for some reason, our line is way off to the side. So let's fix that. I'm going to delete that. We can keep that whole point. And we're going to, let's just pick 2 points on our arcs. And then pick that hole, pick that point, and click our midpoint of our arc. We'll do the same thing over here. Remember, this is floating right now, so we're going to pick that and our midpoint of our arc, and then we can pick the hole, the point there, and go midpoint of our line, and there it should be fully constrained. I don't know why it wasn't fully constrained before. But our holes are a little bit too big for this wall thickness, so we could also make the wall thickness just a little bit bigger to save the time from trying to insert all those and finding a different, insert. I'm just going to make the wall thickness 6 mils, and this should solve it. There we go. It's not breaking through the side over there. I think this is fine over here. Yeah, that's all looking really good. Okay, so we've got all of the hole positions. We're going to do the same thing on our holding box over here. So I'll do that real quick. It's the same method. Let's do it. For here, we're actually going to use the project tool, and we're going to project this closed profile. Let's go OK, and that will project all that geometry. And remember, we created a sketch on this face, but it doesn't automatically inherit all of the geometry on another face unless it's on the exact same face. So even though it's on the same plane, it's not on the same face. So we have to make sure to project that in. So let's create some lines here. Now I should have pressed construction line ahead of time, but I didn't. So now I have to click on them as individuals and press the X key to make them construction lines. Now I want to make these lines exactly in line with each other. So how can we do that? Well, there's a couple different ways. I'm going to pick this line and go collinear and pick that one. We could also go like this. We could pick horizontal, vertical, and pick the end points, and that will make it horizontal with each other. They're both very similar. Very good. And now when we create a dimension from there to there, which is going to be our wall thickness, and actually our wall thickness divided by 2. Now these are exactly in line with each other. Now this other one, I want to create this a little bit more deep into our part. So we're going to go wall thickness and just leave it at wall thickness right there. There we go. So now we're going to create our individual points at our center points there. These are going to be the center points for our holes. Let's finish our sketch. And we can create our holes again on those. And it should default to the hole dimensions that we just created. There we have it. So the reason why I put these in a little bit is that so that they won't interfere with the hole locations on this face. So let's continue on going. So you can see there, that's one single face along the same plane. It will select all of those profiles together. So now we can, again, at this point, let's press X and it will default everything to construction lines. Let's make them collinear to each other. Oh, and these ones in the corner, actually, I want to make right in the middle, so I'm going to delete those. And we're going to go from corner to corner instead. And these ones, we want to do the full wall thickness away. Perfect. And our center points. Now we can create all of our holes. Perfect. And you can see if these will actually interfere with each other, you would be able to see, and they are. So we have to go a little bit further so that they don't impact each other. So all we have to do is go to our individual sketches and just increase this a little bit. So I'm going to go times 1.5. Why not? There we go. And we're going to go back to this one and do the exact same thing. Times 1.5. Perfect. So it's just going to make it so that there's no interference between those two inserts right there. So now before we start joining those threaded inserts into our box and holding tank over here, we want to create the countersunk holes for our flat-headed screws on the acrylic and on the holding tank top over here. So let's go to our box display first of all. Let's make it active. We're going to create a sketch on that. Now here's the cool thing. We're going to hide the display right now. Let's do that. And we're going to project this entire face with all of its geometry. What that's going to do is it's going to take all of that geometry there and place it on our box display top. If I go OK right now, it's going to bring up an alarm. It's going to say, oh, it's not visible. That's because we're hiding our box display. So let's make that visible. And you can see now all of this geometry has come through. There we go. We've got our center point there for all of our screw locations. There we go. So our relief is a little bit too big right now. Obviously, it's okay that the screw actually hangs off the edge there a little bit, but let's go back to our parameters and make our relief just 0.5 mils. And there we go. Everything should update. Perfect. Now our screw is probably just going to hang off a little bit at the most of that, which that's okay by me. Very good. And over here too, yeah, as long as it's not actually hitting our main box, we should be good to go. So we've got that. Now let's go to our hole command. We're going to pick all those center points. And here we're going to create a clearance. So this is when we select clearance, it will allow us to pick a screw size and then create clearance dimensions for that particular screw. So we want a flathead M2. We actually want an M3. And there we go. It's going to cut all the way through there. And we don't want it to cut through our box and holding tank. So we're going to turn that off. It's just going to cut through our box display. And there we have it right there. Okay, perfect. So one thing that we can do is just to make it look a little bit more like the box that we want it to look like is we're going to go to A for appearances and we're going to search for acrylic. And acrylic clear, we're just going to drag and drop on that. There we go. Now we can actually see the holes lining up a little bit more. That's looking really good. Okay, and we can make our holding tank display. We're going to drag and drop acrylic on that as well. So now both of these are see-through, which is looking really good. So we're going to do the exact same method to the holding tank display and the top. We're going to project those features so that we can create the clearance holes for our screws. Okay, so now we've got all of the clearance holes for our screws. We've got all of our holes for the threaded inserts, and now we can start assembling everything. So what we can do is let's hide the display, the top and the box display. We can find this threaded insert over there. bring it off to the side and we can joint it together. So let's go over here to joint. And again, we can actually, because we're joining different components, we can go to our main assembly, our master assembly, and join that. To pick the center of our threaded insert here, we're going to pick our face, and it turns blue, and then it will snap to the center location. There we go. Do the same thing here. Pick the face, it will snap to that center location, and this obviously needs to be flipped, so we can flip it, and there we have it. So here's a really cool feature. We can go duplicate with joints, and we can select this threaded insert there, and then just go to our face, our center. It will add another one right at that location. We don't have to download all of them again and again and again, or we don't have to put them in manually. We can just go duplicate with joints, and there we have it. And that's it. We've got all of them in. So these, unfortunately, oh no, I've done it wrong. So I've put all of them under our Formicarium tutorial master assembly. So what I can do is just select all those, and I'm going to drag and drop them under the fasteners folder, and it will put them all there instead, which is great. Now let's hide all of those joints. Let's just pick 1 through 12 and go to show hide. Very good. Those are looking great. So they are brass. So why don't we just change them to brass color? We can go A, find brass in our appearances, polish, and we're just going to drag and drop it under the entire folder there, and it will make all of them brass instantaneously. So there we go. Now let's add these screws. So remember, our screws are going to be at least 5 millimeters, which is our wall thickness, plus 3 millimeters, which is the length of our threaded insert right there. So it's going to be 8 millimeters long. So we can go to our fasteners folder, activate it. Let's find the right screw. There we go. We're just gonna, let's get some stainless ones here. And again, our step file needs to be selected. Let's go download. Move this off to the side, and we'll do the exact same thing. We'll lather, rinse, and repeat with what we just did. And now we can see how long these screws are. If it's correct, we can just pick this threaded insert and hide it. And yeah, that should be fine. We could have gone a little bit longer if we wanted, but anyways, that's part of what Fusion does. We can see the length of things and make sure that we pick the right lengths before we buy them. So let's go back to our duplicate with joints. And what we can do is go to fasteners this time. There we go. So it's going to put all of their screws underneath that one. We can pick our screw and just duplicate all of them. So you can see this last one was put off to the side. We're just going to delete that. Let's delete it. And then we can go back to our duplicate with joints. And let's just pick that one and pick the right spot this time. There we have it. Now these were supposed to be stainless. So what I'm going to do is, remember we ended up adding brass to all of the fasteners. We don't want to do that. We're going to go back to A, and we're going to make sure that these threaded inserts are going to be all brass, and then we're going to go stainless steel polished. Very good. And we're going to pick all of our screws and drag and drop there. There we go. So if we zoom in, we've got stainless steel and brass. That's looking all great. So all our fasteners are underneath one folder. We can go to our master assembly and go show all bodies. Let's go show all components. There we have it. Let's hide the rest of our joints. There's so many joints right now with all of the fasteners. Now this is looking great. So now we only have a few different things to put in. We're going to put the little gateway for the ants to go through from the holding tank into the main compartment. So let's just go there. We're going to hide the box display, the top there, and the fasteners. And we're going to create this little passageway over here. Now remember, this is going to be 3D printed in the Z direction, or sorry, in the up direction here, which is actually our Y on our model. So we're going to create this passageway. We're going to create it on this face. And this is a really cool thing. We can't see that face right now because we've got this other face, the right wall, in our way. So we can go slice. It will slice everything through there. And now we can create this passageway for the ants right where we'd like it to be. So let's create this, this line here. And we're going to go just something simple. And you know what we can do? Our 3D printer can go 45 degrees. So I'm just going to create a little triangle like this. And let's make this passageway 20 mils, something like that. And so look at here, we're wondering what needs to be constrained. And we just grab a point that's not constrained and move it. So here we're going to create in between there, and we're going to call this 45 degrees. Excellent. And we can, yeah, let's just leave it there. Finish. Perfect. And now we should be able to extrude this all the way through to the other side. Let's go to Object. Boom, right there. That should be big enough for the ants to go through. That's excellent. And unfortunately, look at where we've created it. We've created it underneath our master assembly. So again, now it's created an entirely new sketches folder. So we've done that wrong. We have to go delete that. Yeah, it's going to delete the extrude as well. We have to delete that. And now we have to activate our box and holding tank and do the exact same thing. Now that particular sketch and extrude are going to be found underneath our box and holding tank component rather than under our master assembly over here. Great. So the last two things that we want to do are going to create the holes for our test tubes. And one of them is to allow moisture in. The other one is, I believe, to allow ants in, or some sort of creatures or food or something like that. I'm not quite sure. I'd love to see this final product printed and assembled with ants in it. That would be really cool. So let's just create those points for, or those holes for our test tube. So what I'm going to do is I am going to create it. We could create it on the inside, but what I'll do is, you know what, we'll just create it on the outside here. Yeah, why don't we just do that? So I'm not sure how big these are. Again, we could make parameters for these, but I'm just going to go, 12. That's probably a little bit too small. So let's go 25. Yeah, let's go 20 instead. I don't just do that. And let's constrain this. So I'm going to put in a dimension here. We can go 40 for sure. And then this, remember, if we're wondering why it's still blue and unconstrained, we can grab it and move it. And here we're going to create a point, snap it to the midpoint there, and say I want these to be horizontal to each other. There we go. Finish sketch. We're going to extrude this through and do the same thing over on this side. So here we're wondering where to place it. Well, this is a cool thing. We can flip on over here, orbit, and press P to project, and project this wall onto the other side. There we go. Now we have something to work with. And what we can do is, let's make it so that the side of our circle is 5 millimeters from this wall and 5 millimeters from that. So if we press D and we pick this outside wall, what is it going to do? It actually goes to our center point. So we need to do something a little different. Press D, right click, pick circle arc tangent. Let's pick that and our line. And now we can specify that distance as 5. We'll do the same thing. D, arc tangent. There we go. And I'm going to pick that dimension, 5 millimeters, 5 millimeters, just like so. And we can go through here to object. Boom, and now it's perfectly placed 5 mils from either side right there. And those are going to be for the test tubes. Excellent. So last but not least, we're going to make the stands for it. Now, what I did in a practice tutorial run is I ended up making a relationship. I ended up projecting the walls of the Formicarium here and creating the stand based on the wall. But remember, the wall thickness is a parameter. It's very easy to have things updated automatically. Here's a fundamental thing about Fusion is the more relationships that we have, the more processes that are run or relationships that are being processed, well, our computer slows down. So if we use fewer relationships, our computer stays nice and fast. So one thing that I also did was when I created a projection here for our stands, it broke for some reason. The model broke. So I ended up just creating our stands with the basic dimensions of our box here and using the parameter for our box depth. So let's create a new component. I'm going to call this stands plural. And within stands, I'm going to create a new component. This is going to be stand. So under stands, we're going to have stand 1, and we're going to copy this, and it's going to be stand 2, but we only have to create the dimensions for one stand. So let's isolate that. Actually, we can isolate this one, and we can create our sketch right there. And let's just, let's have some fun here. So this is going to be, let's make it 70 millimeters tall by our, this is going to be our main box depth right there. And then I'm just going to go around here and I'm going to put the dimensions in slowly for our, oh, now my computer is all dancing on me. It's probably the processing is getting a little bit intense. So we just have to go a little slower here. There we go. I'm putting in the basic shape, and then I'll end up constraining it and putting the dimensions in, or the dimensions in later. So you'll see what this looks like at the very end, but I'm going to create these dimensions. This is going to be the wall thickness. And once I create one dimension, I can actually go to the equal constraint, and I want to say that this edge is going to be the same as that, this is going to be the same as that, and this is going to be the same as that. Saves a lot of time. Then I can go collinear from there to there, and everything looks really good actually. So here, what's wrong? Oh boy, what's wrong? Oh, it's the length, that's right. So we're going to go to, and I actually didn't want that to be collinear. So yeah, I wanted these lines to be collinear. So the top right to there, and that's going to be, now we can go top right to there as well. Perfect. And then this to that. Oh, it's got an angle. So why do we have an angle there? That's why. Okay. So we can just make this vertical. That's it. This one vertical as well. And now I can put a dimension between there and there. And this we're just going to call 30 mils. Do the same thing over here. 30 mils. And this, I'm going to create this at 30 mils as well. It's going to be a little bit shorter in the front so you can see more of the box. There we go. So there's a stand. We're going to extrude this. And before we do that, actually, I'm going to go back to the sketch and I'm going to create a little bit of kind of a fun little thing to do here. Let's go to our center rectangle and I'm going to create just a little, a couple reliefs. But remember with 3D printed materials, if we have sharp edges, they break a lot easier. So I'm going to create some big loopy rads and fillets so that our stand is a lot stronger. So let's go collinear there to there. This is going to be vertically constrained right to there. And now this, we're going to call that, let's call that our wall thickness. Perfect. And what is left over here is the height, and this can actually be our wall thickness as well. Perfect. Everything is constrained. Now let's extrude just like this. And this is going to be extruded, I don't know, let's go 25 mils. Now we're going to put our fillets in there, and you'll see a little bit more what I'm talking about. So let's pick 1, 2, 3, 4. And we can actually pick right through our part here with X-ray vision. I'm going to pick all of those edges. And these are going to be, oh, we can't go 5. Obviously we can't. Let's go 2. So here the box is going to sit on this platform, but these big rads right there are going to keep it so that it's nice and strong. There we go. I like 3 millimeters a little bit more. We're going to add another selection set to these guys and make these even bigger. Let's go 5 mils there. Let's go 10 mils. Oh, there we go. That looks pretty cool. Awesome. So this is one stand. Our stand is finished. We're going to go copy and paste. Don't go paste new. When we go paste, we have the exact same stand 1 or 2. If we activate stand 2, it's the exact same timeline. And in fact, if we change something in the timeline, believe it or not, it goes back to our original stand because they're exactly the same. It's not going to, if we change one, it's going to change the other. Yeah, so there we go. Let's activate our entire assembly, make our box and holding tank visible. We're going to move one stand over there, one stand over there, and join them together. So let's go join this point to there. Go OK, and do the exact same thing over here. And there we have it. So now let's make everything visible. And we've got our last joint over here, last 2 joints. We can hide those. Now let's just test our parameters to see if anything breaks. Let's try it one more time. There's a lot of computing going on here, but nothing is breaking. Everything is looking great. Oh, we've got one issue. We've got this floating. Why is that floating? All right. Let's see where that guy belongs. We can just box display it. Let's see where this particular fastener is. 1, 2, 3. We've got 16. So 1, 2, 3, 4, 5, 6, 7, 8, 10, 16. So where does this guy belong? And how come it's not? Let's hide our stands. Why is it not in location? All those are looking good. Oh, there it is. It's missing over there. Okay, so all we need to do is put that in the right location. Let's hide our screws over there, and we can join this. So, why is this now giving me a hard time? Let's hide that. I don't know where it's actually joining, but let's just see what happens. Oh, it is supposed to be there. I think there is just a little bit of an error going on for some reason. So what I'm going to do is let's just delete. Yeah, let's just delete that entirely. And now it's placed it back there. So okay, well, there we go. Okay, so I think we fixed it. Let's go back there. And again, we're going to go back to our parameters and 500 mils. I think that did it. A nice tall one there. Perfect. So anyways, let's conclude this. Got one more trick for you at the very end, but before we get there, I'd just like to send a shout out to all of our YouTube members, our Patreon members, those who have bought us a coffee, and those who have supported us directly on our Square Up account. We really appreciate it. We are grateful that you find these tutorials beneficial enough that you want to support us. And for that, we are very grateful. We want to show our appreciation. Thank you so much. If you're interested in helping us out or in requesting a special tutorial of any kind, please let us know. And we'll do our best to make a tutorial and post it so that you can benefit from that as well. So please put it in the comments below, anything that you've benefited from or something else that you'd like to see, or if you have any suggestions, we'd love to hear from you too. So the last trick is this. You might notice that we can actually move our components off to the side by just clicking and dragging, which is obviously not going to work well for us. We could always just go revert position. But one last thing I want to share is let's go to Assemble and go to Rigid Group. And we can just pick our components 1, 2, 3, and 4, and we can include child components and go OK. And now you can see that we can't move anything. So we hope that that rigid group trick is helpful to you. Hope to see you at the next tutorial, and thanks for learning with the Learn It channel.